Australians are incredibly lucky because we have spectacular natural landscapes and seascapes that are found nowhere else on the planet. When I went up to the Great Barrier Reef for the first time, I was overwhelmed by the diversity of fish and other marine organisms present, the incredible shapes and colours of the corals, and that fired my passion to want to know more about the foundation of reef systems, which are the corals and the coral communities. Without healthy reefs, we lose potentially 1 million species that occur on our planet. We also lose incredible amounts of value in terms of food resources, but also tourism resources. So part of the coral IVF restoration process is to regenerate the reef system so that we have healthy, thriving reef communities into the future. Surprisingly, around the world, researchers knew very little about how corals reproduced and when they reproduced. The reason that's really important is that unless we understand how these organisms that form the reef reproduce, we can't begin to understand how to help manage them. So a team of us banded together and we got a small grant from the Great Barrier Reef Marine Park Authority. And what we discovered was that 4, 5 and 6 nights after the full moon, many different types of corals spawn together. And as I'm swimming through, I was thinking, instead of the larvae drifting away, if we could just culture some of them, maintain them on the reef system during their 5 to 7 day development period, we could target their release back onto the damaged reef areas. So the coral IVF process is designed to use the natural processes of coral spawning to actually effectively restore the reef systems naturally. So once a year, about 4 to 6 nights after a full moon, after these mass spawning events, what we do is capture parts of the spawn slicks that occur at the sea surface, and we take those spawn slicks into special nursery pools that allow seawater to flow through it, but retain these microscopic larvae within it. For the next 5 to 7 days, we then monitor the development of the larvae, making sure that we've got high rates of fertilisation. We then concentrate the larvae and either open the bottom of the net so that the larvae drift out over the reef area nearby, or target their release back onto the damaged reef areas. One of the really interesting things we've been doing recently is I've been working with a robotics expert, Professor Matt Dunbabin, and together we've come up with the idea of a thing called LarvalBot. LarvalBot is the world's first underwater robotic vehicle that's designed to deliver coral larvae directly where they're most needed on the reef system. It's a really exciting blend of ecology and technology, and we hope that this will transform reef restoration not only for the Great Barrier Reef, but for other reefs around the world. The most exciting part is swimming back over reef systems and seeing baby corals developing on the reef. But even more exciting was that some of the new surviving corals actually grew to reproductive size in 2 years, which is a world record. I've been incredibly fortunate during my career to see absolutely spectacular reef systems that are so beautiful that they're overwhelming. And I won't rest until we've been successful at doing this at much larger scales to take reef restoration to the next level.